Okay, so right now we're going to look at system of equations and word problems again. So we have Felix flies his private plane from Baltimore to North Carolina and back in one day. It's a 300-mile trip, and going there against the wind takes him 5 hours. Coming back with the wind takes him 3 hours. What is the speed of the plane, and what is the speed of the wind? Okay, so like the previous ones, the first thing I want to do is find what I'm looking for. So again, it's going to be the thing in front of the question mark. So I'm looking for the speed of the wind and speed of the plane. Those are both numbers, so it's a good thing to be looking for in a math problem. So speed plane and speed wind. I'm going to call them something. Those are what I want to know. So they're my unknowns. Those are my variables. And they will be my only variables. This time I don't really have totals. I mean, I have some totals. It is a 300-mile trip, but I don't have miles to add to it, so I can't total something to give me 300. Same thing with hours. I have 2 hours. They add to 8, but it's not really going to help. I can't get an equation out of that. So I'm going to look for another kind of just real-world phrase that I know that can turn into a math expression. In this case, speed. Speed is something that all of us have seen before, and speed is often written, at least when you're driving, or maybe flying. I don't fly, I have no idea. As miles per hour, or more generally, distance over time. If you've taken physics before, this is where you will see the rate times time equals distance formula. You just multiply both sides by time. We're going to leave it like this though. Speed equals miles per hour. It's going to help us out a lot in this section. So, I have 2 trips though, so I'm going to separate my 2 trips because they have different speeds. So I got one trip going down there, and that one trip going down there is against the wind. Then I have a trip coming back. That trip coming back is with the wind. Let's see, trip going down there. I don't know my speed, so I'm not really going to fill that in. But I do know my miles. My miles is 300, in fact, for both trips. And my hours. Against the wind, it was 5 hours. With the wind, it was 3 hours. Okay, so I got that part filled in. Let me think a little bit. If I have a plane, and my plane is flying one way, this is my plane, and the wind all of a sudden is coming along and pushing it along, so it's going with the wind, then that means the wind is going to make the plane go a little faster. Say my plane is going 300 miles per hour, the wind perhaps is 50. If that wind is behind it, pushing onto it, it's going to add that 50 miles per hour to the total speed. So with the wind, we take the plane speed, and we add the wind to it. Against the wind is the exact opposite. So my wind this time would be pushing against it. And so again, let's say it's 50 miles per hour. So if it's pushing against it, it's slowing it down by that much. So instead of adding, I'm going to slow it down, I'm going to subtract that 50 from it. So against the wind, I'm going to speed the plane minus the speed of the wind. Now I have nice little elimination problem set up right here. If I just do the division, P minus W equals 300 divided by 5 should give me 60. P plus W should equal 100. I have the minus W and the plus W, so I can straight up just add them. P and P should give me 2P. Make sure my W's cancel out. They do. 160. So P equals 80. Can sub it into either of my 2 equations to find my W. I'll just sub it into the second one. So let's see. 80 plus W equals 100. Well, 80 plus what equals 100? 20. So W has to equal 20. Or you could subtract 80 from both sides. That's fine. Check with the other one. 80 minus 20 equals 60. So it works for both equations. Okay, let's try this one more time. In 1950, Florence May Chadwick became the fastest person to ever cross the 21-mile English Channel both ways. She's since been beat, but she's interesting. Swimming from France to England with the current took her 12 hours. Coming back against the current took her 16 hours. How fast was she swimming, and how fast was the current? So again, what are we looking for? We're looking for her speed, how fast would be a rate or speed, and we're looking for the current. So speed of Florence, I'll call that F, and speed of current, I'll call that C. Okay, so I have again 2 trips. She is going with the current, and she is going against the current. So with the current, I can probably set up the speed right away. I'm going to use that same equation since I have speed in here. So miles per hour. So speed with the current, then the current is pushing her along faster, so I'm going to add it. It's a 21-mile trip over, she did it in 12 hours. That's actually a lie. She took a little longer than that, but I wanted the numbers to work out better. Against the current, this time the current is slowing her down, so I'm going to subtract it. It's again a 21-mile trip, and it took her 16 hours. So I have a nice little elimination problem. Before I actually do the elimination problem though, let's go ahead and simplify my fractions if I can. F plus C equals 21 over 12. 3 goes into both, so 7 over 4. F minus C, can't simplify that one, so 21 over 16. So plus C minus C, they will cancel out. I'll have 2F equals, I need to add these together. To add them, I need to find a common denominator. So I'll multiply that top fraction times 4 over 4. So 28 over 16 plus 21 over 16. So 2F equals 49 over 16. Divide both sides by 2. If you remember how to divide fractions, all you do is flip the second fraction and multiply. So I should get F to equal 49 over 32. Okay, so now I can go ahead and sub that back in to find my current. So if I have something like, let's sub it into, I guess, the first one, 49 over 32 equals, or I'm sorry, plus C equals 21 over 12. Probably should have done the second one. Doesn't really matter. I can still just simplify that one. Okay, so 21 over 12 is still simplified to 7 over 4. Find a common denominator. I'll multiply it by 8 over 8. So 49 over 32 plus C equals 56 over 32. So C is going to equal, subtract 49 over 32 from both sides, 7 over 32. So she seemed to have a pretty light current, yet she was also swimming a bit over a mile per hour. That's pretty exciting. Okay, well, hopefully that makes sense. You could check this, but considering they're kind of horrible numbers, you can also just diss on checking them.